Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of functions. As per the problem, provide an equation of a function with the following properties, and we are given these three different function properties. The answers for this question can vary. So let's start with part A. As per the problem, the function has no intervals of decrease. The function increases from negative infinity to negative 1 and then negative 1 to positive infinity, and the domain is negative infinity to positive infinity. Since there is no break in the domain, this function can be a polynomial function or an absolute value function. It cannot be a square root function or the reciprocal function. Since the function has no interval of decrease, it cannot be absolute value function. So this must be a polynomial function. So let's sketch the given information. The domain is all the way from negative infinity to positive infinity. There is no break in the function. The function is increasing from negative infinity to negative 1 and negative 1 to positive infinity. That means at negative 1, the graph of the function becomes horizontal. So we can use a cubic function. So we can show the sketch of the function like this. So as we can see, the function is increasing all the way from negative infinity to negative 1, and then it continues increasing from negative 1 to positive infinity. That means on the right side of negative 1, the graph keeps going upward. So the rest of the graph can be like this. Let's assume the graph is horizontal at x equals negative 1. Let's assume the y value is 2. We can write the general equation for a transformed cubic function. The graph for base cubic function looks something like this. So we can see that there has been a horizontal translation 1 unit, vertical translation 2 units up. There is no reflection in the x-axis or y-axis. So we can assume a is equal to 1, b is equal to 1, h is equal to negative 1, and k is equal to 2. Now we can sub in these values. A is 1, so we can ignore it. B is 1, so we can ignore it. X minus negative 1 is equivalent to x plus 1. So this can be the equation for the function in part A. Now we can answer part B. The domain of the function is x can be any real number except negative 4. The range is any real number except 2. And there is no interval of decrease. Since there is a restriction on the domain and range, this must be a reciprocal function. There is a vertical asymptote at x equals negative 4 and horizontal asymptote at y equals 2. So we can sketch this information. As per the problem, this function has no interval of decrease. That means the function is increasing for all x values. That means as we go along the graph from left to right, the function value should increase. The graph of a reciprocal function is shown as two curves. So we can show the curves in this case. So this can be the first curve and this can be the second curve for this function. Now we can write the equation. So let's start by writing the general equation of a transformed reciprocal function. The graph of base reciprocal function is in quadrant 1 and quadrant 3. In this case, the curves are in quadrant 2 and 4. So we can assume that there is a reflection over the x-axis. So a can be equal to -1, b is equal to 1, because there is no reflection across the y-axis. H is for horizontal translation. In this case, there is a horizontal translation 4 units to the left. So H is equal to -4 and K is equal to +2 because the horizontal asymptote has been moved 2 units up. Now we can sub in the values. We can ignore the b because 1 times the parentheses won't change the parentheses. X minus -4 is equivalent to x plus 4. So this can be the final answer for part B. Now we can answer part C. The given domain is any real number from -3 to +3. The range is any real number from -5 to -2. Interval of decrease is from -3 to 0. So let's sketch this information. The domain is from -3 to +3. Range is from -2 to -5. The interval of decrease is from -3 to 0. That means the interval of increase is from 0 to 3 because the domain is from -3 to +3. That means the graph should go down from left to right from -3 to 0 along the x-axis and should go up from 0 to 3 as we go along the x-axis. So one possible shape for this graph can be a semicircle. The radius of this semicircle will be 3. The center of the semicircle is at -2 on the y-axis, 0, -2. Now we can write the general transformed equation for a semicircle. The radius is 3, so we can sub in r as 3, so r square will be equal to 9. The graph of the base or parent semicircle function is a semicircle whose center is at 0, 0 origin and is above the x-axis. That means this function has been reflected over the x-axis. So a value can be equal to -1, b can be equal to 1. There is no horizontal translation, so h is 0. And there is vertical translation 2 units down, so k is equal to -2. Now we can sub in these values in the general equation. B is 1, so we can ignore it. H is 0, so we just get x squared. So this can be the equation of the function in part C. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.